This new section is entitled the right angle theorem. Basically, the right angle theorem says the following. If you have a straight line, it's 180 degrees. And two angles are supplementary if they add up to 180. Here's 180 degree angle. Let me break it up into two pieces. That piece, that angle, and this bigger angle. Be very clear. This angle here and that angle there. They add up to 180. They are supplementary angles. A, B, C, D. Angle ABC, this angle, and angle DBC, this angle. They are supplementary. They add up to 180. Well, what if these two angles were in fact equal to one another? That is, let's suppose two things, that these angles are supplementary. That is, they add up to 180. And suppose you come to know that angle ABC is equal, the measure of angle ABC, the sum of the measures. Suppose you come to know that measure of angle ABC is equal to the measure of angle DBC. Well, that means wherever you see the measure of angle DBC, wherever you see the measure of angle DBC, you can put the measure of angle ABC, because they're equal. And this is 180. And when you add two things, we're adding two things that are exactly the same. So you get 2 times the measure of angle ABC is 180. Dividing both sides by 2, each angle must be 90. That is, the measure of angle ABC must be 90 degrees. But measure of angle ABC and DBC are equal. So the measure of angle DBC is also 90. If two numbers add up to 180 and they're both the same number, well then, that's 90 degrees and that's 90 degrees. They can both be 30. 30 plus 30, well, 30 and 30 are equal, but they don't add up to 180. If two angles add up to 180 and they're equal to one another, they're both 90 degrees, you have a right angle. That's the main thing for this section, the right angle theorem. Suppose you have a triangle like such. Triangle ABC. A, B, C. And you're given that AB and AC are equal. And you also drop a line. You drop a line. Call this point down here D. And you're also told that BD and DC are equal. And you want to prove that AD is an altitude. So you are given a triangle where AB and AC are congruent. That is, you have an isosceles triangle. ABC is isosceles. And you're also given that BD is congruent to CD. And you're given line segment AD. And you want to prove that AD is an altitude. Well, has a good shot. It starts at a vertex, starts at vertex A, and it goes to the opposite side. All I have to prove is it's a right angle. Now, clearly, this angle and this angle add up to 180. So, straight line. I just have to show that they're equal in one another. If I can show that that angle and that angle are equal, then I can say they're both 90 degrees, and AD will in fact be an altitude. All I need to show, if you have any triangle, and you go from any vertex, say that vertex, and you go to the opposite side, that line I just drew will be an altitude only if those angles are right angle. If that's the right angle. If you come down here and that's the right angle, you say it is, you say that this line is an altitude. The altitude is probably this line because it meets at a right angle. If you have this triangle, that will probably be the altitude because it looks like that's the one that meets at a right angle. But whichever one it is, maybe I'm off a little bit. Maybe it should be that line. Fine, it's that line. As long as it meets at a right angle, and only one of the lines will. You have a lot of lines that I can draw from point A. But only one of them, say this nice blue one, only one of them will meet at a right angle to the line in the bottom. Call it line BC. And if it does, it's an altitude. Okay, so we need to prove that this is an altitude, that AD is an altitude. So I just want to prove that those two angles that have check marks are equal. Well, one way to do that is to show that the two triangles, the one on the left side and the one on the right side, triangle 1 and 2, are congruent, and those two check mark angles are corresponding parts. Alright, so statement and reasons. I'm going to show that they have the same, that triangle 1 and triangle 2 have the same three sides. We have the given. 1 is the given. So, in particular, we're told that. So what I have marked on the triangle is correct now. Okay, the 1 slash and the 2 slash are equal. Now I'm going to say that AD is congruent to AD, not AP, AD. That side is congruent to itself. That's kind of obvious. And that's called the reflexive property. Reflexive property. Well, that's enough for me. Triangle ABD is congruent to triangle ACD. The reason is side, side, side is congruent to side, side, side. Statement 4. Let's call this angle 1 and angle 2. Angle 1 is congruent to angle 2. And the reason is angle 1 is made up of the side that has the X and the side that has 2 slashes. Angle 2 is made up of the side with X and the side that has 2 slashes. They really do correspond. Corresponding parts of congruent triangles are in fact congruent. Okay, now I will say angle BDC, the measure of angle BDC, 180 degrees. all straight angles equals 180 degrees. Okay, and that's where I have it. Angle 1 plus angle 2 equals 180 degrees. The sum of the parts equal the whole. The sum of the parts equal the whole. Okay, angle 1 plus angle 2 is 180, but they're equal. They're equal. Angle 1 is equal to angle 2, which is equal to 90 degrees. Two supplementary angles are equal, they both equal 90 degrees. If two supplement angles are equal, then they equal 90 degrees. That was the main theorem of this section. Okay, so angle 1, it's just enough for me to say angle 1 is 90 degrees. Okay, so statement 8 and reason. Statement 8 is going to be that our AD is an altitude. Reason is AD meets BC at a right angle. Yeah, if I want to really nail this down, is I can say angle 1 and angle 2 are in fact right angles. And the reason is all 90-degree angles are right. All 90-degree angles are right angles. All 90-degree angles are in fact right angles. And then AD meets BC at a right angle. That's why AD is an altitude. AD is an altitude because it meets the opposite side at a right angle. That's this one. Again, if two angles are supplementary and they're equal. That is if two angles lie on a straight line. If two angles lie on a straight line. Here is a straight line, and here are two angles. This angle and that angle. They're on a straight line. If they're equal, here are two angles. This angle and this angle. And they lie in a straight line. If they're equal, well then, they're right angles. That's what this whole theorem is stating. Okay? Study that theorem. But also understand it. Don't memorize this stuff. It's too hard to memorize. It's a lot easier to understand it. Okay. Suppose we have this figure. Looks like a kite. Suppose we have this figure. I'll naturally call it A, B, C, D, and E. And there are some things that are given. We're given that AB and AD are congruent. We're given that BC and DC are congruent. We want to prove that one diagonal, AC, is the perpendicular bisector of BD. AC bisects BD. That is, it cut BD into 2 equal parts. But we don't know that yet, so I won't put the slashes. And not only does it bisect it, it's the perpendicular bisector. It must cut it like that. Now, are all perpendicular, if 2 lines meet at, the 2 lines are perpendicular, are they always a bisector? Of course not. In theory, we could have had this picture. This is B and D, and AC meets BD at a right angle, but it isn't the case where this length and this little bitty lengths are equal to one another. It was a perpendicular. AC and BD are perpendicular, but it wasn't a bisector. Now, to be a bisector, you don't have to be perpendicular. Well, here's a length. Here's BD. Here's AC. And AC split BD into 2 equal parts. This part and this part, they're equal. But they're not right angles. Nope. They're not right angles. But in our case, it's both. The 2 lines are perpendicular, and in fact, they bisected one another. Now, before I confuse myself, let me get rid of that right angle up there by E, because I don't know yet that it's right. Okay. So, when I look at the left big triangle, the one separated by BD, BDA. This is an isosceles triangle. How do I know that? Because of those sides being equal. That means this angle here and this angle down here are equal. We'll call them angle 1 as opposed to angle 11. Okay, angle 1. Now, same thing for the right side. Triangle BCD, we have these 2 slashes. That means their base angles are equal. Okay, so we have that. All right. Now, I claim that this upper triangle and this lower triangle, they are congruent. And the reason is because they have another side equal. Well, that's not true. That's not true. Well, call this angles 3. Well, then this must also be angles 3 because opposite sides are equal. And we'll call this 4. And we'll call that 4 because opposite sides are equal. Opposite angles are equal. All right. Okay. So let's look at this triangle down here. A, D, C. This has 1 slash, this has 2 slashes, and this angle is angle 1 plus 2. The sum of the parts is the whole. Now, if we look at this angle, the triangle above it, A, B, C, this is angle 1 plus 2, 1 slash, 2 slashes, and in fact, the third sides are the same. Those 2 triangles are congruent by side, angle, side. side, angle, side. What that tells me is this angle, let's call it angle 5, this angle and this angle are equal, and this angle and this angle are equal. So let me draw this picture a little bit bigger. A, B, C, and D. So right now, we know that these two angles are 5 and these two angles are number 6. And this is 1 and 2. And this is also 1 and 2. All right. And these are equal, and these two are equal, and AC is equal to itself. Okay. So what I have is this triangle here and this triangle here are congruent. Angle 5, 1 slash, and angle 1. 5, 1 slash, and 1. So those are congruent by SAS. That tells me that this angle and this angle are equal. That tells me that those two angles are equal. But wait a minute. That's 180 degrees. That means that those two angles are both 90. Okay, so we satisfied one thing. I showed that the two angles are both 90. So these are now both right angles. This is the right angle, and this is the right angle. I want to show that AC bisected. Already showed that it's perpendicular to BD, but it bisects BD. That is, I want to show, guess this was E. I want to show that BE and DE are the same lengths, but they're corresponding. We know that triangle 1 and triangle 2 are congruent. Well, opposite angle 5 is BE, and opposite angle 5 is DE. In fact, BE and ED are congruent. Now, in terms of writing that off, that's just going to take too long. But what I will do is go over it again. Don't have a problem going over it yet again. A, B, C, D, and point E. So we are told that AB and AD are equal, and BC and CD are equal. Right. So that immediately tells me, looking in the left triangle, since these two sides are equal, these two base angles are equal. Same argument on the right side. These two are equal. Okay. Now, if I look at the lower triangle, the triangle below AC, it has 1 slash, the angle in the middle is 1 plus 2, and 2 slashes. The same thing with the top triangle. It has 1 slash, has a side with 2 slashes, and in the middle, 1 plus 2. by side angle side. The top half and the bottom half are equal to one another. Okay, so that tells me that these two sides, well, excuse me, that's true too, but it tells me that BE and DE are equal. That is, AC cut BD in half. Now I need to show that this angle and that angle, or X and that Y, are equal to one another. But that's immediate. That's immediate. Because on the left side, the top and bottom are congruent. Because in this triangle, you have one slash, you have angle 1 in the middle, and 2 slashes. That is, you have one slash and an X and angle 1 in the middle. In the lower triangle, triangle 2, you have one slash, X, and angle 1 in the middle. Those two triangles are congruent. Opposite side 1 are congruent angles. Angle X equals angle Y. But angle X and Y lie on a straight line. Hence they're supplementary. Angle X and angle Y are supplementary. And they are equal. By our theorem, angle X and angle Y are 90 degrees. Or just angle X is 90 degrees. But that's enough for me, because what we showed up to now is the following. We showed that this piece and this piece are equal in lengths. That is, BD was split in half right here. And this line, AC, and BD were perpendicular. So here, AC is the perpendicular bisector of BD. Okay, that's probably a 10 to 15 step proof. But I told you all the steps. Now you just need to write them up. Let's have a look at this one. Have a circle. The center of the circle is point P. And you have a chord. A chord is any line that goes from one point of a circle to another. Say Q to R. And I come down to point S. And we are given some things. For example, we are given circle P. A circle is always defined by a center, which we call P. And it says that S is the midpoint of QR. And we want to prove that those two lines meet at a right angle. PS and QR are perpendicular. Okay. So what we know is S is the midpoint of QR. So we know that these two are equal. Okay. Well, if I were to draw those two lines, I know that they are equal. And they are equal because they're both radii. They go from the center of a circle to a point on a circle. Those are both equal. And what that tells me, if I look at the triangle QPR, the whole big triangle, since these two sides are equal to one another, I know that these two angles are equal to one another. So now the left triangle and the right triangle are similar by side, side, and the angle in the middle. On the left side, I have 2 slashes and 1 slash corresponding to triangle 1, and the angle in the middle. So by side, angle, side, these 2 triangles are congruent. Let me draw this triangle bigger, a lot bigger. Here's P, here's QS, Q, and R. Since these 2 are both radii, they're equal to one another, and then we have a big isosceles triangle. There it is, without the PS. That's an isosceles triangle. So the base angles are equal. Okay, and we also were given that that S, the midpoint of QR. So S split QR into 2 equal pieces. Well, in the left triangle, I have one side with 1 slash and one side with a second slash. In triangle 2, I also have one side, SR, with 1 slash, and PR with 2 slashes. And the angle in the middle are equal. So by side, angle, side, side, angle, side, these 2 triangles are congruent. Well, opposite, say, the side with 2 slashes is this angle, and opposite the side with 2 slashes is that angle. Well, those 2 angles are equal, but they make up a right angle. Okay, so let's write all of this up. And since they're both equal, since they're right angles, that's what we wanted. We wanted to prove that PS is perpendicular to QR. Okay, so this time we'll start with our bigger circle. The center is P, and you have some line QR, was it? QR. And P comes down and meets the line at S. And we are told, so we're given circle P, so statement and reasons. Statement 1, it's everything that's given. The reason that I can put it down is it's given. 2, want to say that QS is congruent to RS. The reason is a midpoint divides a line segment into 2 equal parts. Okay, statement number 3. Draw QP and QR. Now, I don't know what the statement is. I'll call it construction. You can construct 2 lines. Number 4, I will say that QP is congruent. Or, first let me say that they're radii. QP, so first let me draw it. QP and PR are radii. And the reason is any line from the center of a circle to a point on the circle is a radius. Now I have that they are radii. So now statement 5 is I can say that QP is congruent to QR. Have to nail down everything. Can't leave any detail not explained or left out. All radii are equal in length. Okay, number 6. Okay, so we've argued why those two on the base are, QS and SR are equal. We just talked about why QP and RP are equal. Now I'm going to say that, I want to say that this angle here and that angle there are equal because isosceles triangle. So first I have to say that triangle QPR is isosceles. And the reason is, if two sides of a triangle are equal, then it's isosceles. Two sides equal. Number 7. Angle Q equals angle R. Base angles of an isosceles triangle are equal. Base angles of an isosceles triangle are equal. Let us continue over here, please. So the base angles are equal. So now I can say that triangle 1, PQS, is congruent to PRS, to triangle 2. And the reason is SAS. Side angle side is congruent to side angle side. In triangle 1, I have a side with 1 slash and a side with 2 slashes. Same with the second triangle. 1 slash and 2 slashes. And the angle in the middle, oh, they're equal. I know they are. I just said that in statement 7. Okay, so these two triangles are congruent. So let's call this angle 1 here and angle 2 here. Statement 9 is angle 1 is congruent to angle 2. The reason is corresponding parts of congruent triangles are congruent. They're both, angle 1 is opposite the side with 2 slashes, so with angle 2. They're in the same location. Alright. Angle 1 and angle 2 are supplementary. The reason is they lie on a straight line. They lie on a straight line. Statement 11 would be angle 1 is a right angle. Angle 1 and angle 2 are right angles. Why? Because if two angles form a straight angle and they are equal to one another, they are right angles. That's the main theorem for this section. If two angles are supplementary and they are equal, they're supplementary, 1 and 2, and they are equal or congruent. They are 90-degree angles. So statement 11 would be angle 1 and angle 2 are right angles. So now we have angle 1 is a right angle. Therefore, statement 12 can be PS and QR are perpendicular. Why? Because they meet at a right angle. They meet at right angles. So statement 11 would be angle 1 and angle 2 are right angles. Reason? If two angles are equal to one another and they are supplementary to one another, they are 90-degree angles. Number 12 would be that PS is perpendicular to QR. These two lines are in fact perpendicular. Why? Angle 1, they meet at right angles. Okay, so that's that one. Let's do a couple more. Suppose you have a triangle ABC, and you have a line that comes down to point D. And you are given the following. You are given the following, that CD bisects angle C. And you're given that angle A is congruent to angle B. And you want to prove that AD is an altitude. We want to prove that AD is an altitude. Okay. So let's see how we're going to do this. CD, this line CD, bisects the angle C at the top. That is, these two angles are in fact equal. And you're told that angle A and angle B are equal. Well, we proved earlier tonight that if you have two triangles, the one on the left, say, and the one on the right, and then you have two pair of corresponding angles. If two angles of triangle 1, namely angle A and the one that we called angle 1, if they correspond to two or are congruent to a pair of angles in triangle 2, like 1 and 2 are congruent, and A and B are congruent. Well, then the third pair of angles are equal. Angles 3 and angle 4 are equal. But that's where we have it. Oh, if I want to show that AD is an altitude, I really want to show that angle 3 or 4 is a right angle. That's my whole goal. Well, whenever you have a straight angle, and you want to show that a line meets at it perpendicular, you want to show that both of these are 90. That is, I want to show that they're equal and supplementary. If two angles are equal, if angles 3 and angle 4 are equal, and they're supplementary, then they're 90-degree angles. But that's what we have. If you have two triangles and they both have a pair of congruent angles amongst them, then the third angles are equal. The third angles correspond. 3 and 4 are congruent. 3 and 4 are congruent. That is, they're equal to one another, and they form a straight line. They are 90-degree angles. So statement, reasons. Statement 1, put whatever your teacher likes you to put. If you're the teacher, you tell them what to put. Just make up something. If you're not sure what to tell them, put the givens. Put it. Number 2. Angle 1 is congruent to angle 2. So we do, in fact, have that. And, in a moment, I have to write the reason, and we're having A and B are congruent. So, let's see. Angle 1 equals angle 2. And angle bisector splits an angle into two equal parts. Okay, number 3. Angle 3 corresponds to angle 4. If you have two triangles and two angles of one triangle are congruent to two angles of a second triangle, then their, we'll call it remaining. Then the remaining two angles are congruent. Okay, statement 4. Angle 3 equals angle 4 equals 90 degrees. The reason is, if two equal angles are supplementary, they both equal 90 degrees. If two supplementary angles are equal, then they equal 90 degrees. 5. Angle 3 and angle 4 are right angles. The reason is, all 90 degree angles are right angles. All 90 degree angles are right. Number 6. CD is perpendicular to our AB. And the reason is, two lines are perpendicular if they meet at right angles. We've already said that angle 3 is a right angle. Two lines are perpendicular if they meet at right angles. Now, we don't need that. Excuse me. We don't need that. It wasn't wrong. We just don't need it. ACD is an altitude to triangle ABC. Why is CD an altitude? Reason, because CD meets AB at a right angle. CD meets AB at a right angle. That's what makes it an altitude. Okay, that completes this section. Try some of these, they're fun.